On July 17th, 1998, the remains of the last Emperor of Russia, Tsar Nicholas II, his wife, Tsarina Alexandra, and 3 of their daughters were buried in the Cathedral of Saints Peter and Paul in St. Petersburg. Since the time of Peter the Great, almost all of Imperial Russia's rulers have been buried there. In 2007, the remains of Nicholas and Alexandra's 2 missing children, Tsesarevich Alexei and Grand Duchess Maria, were located and identified. But the plan to bury Alexei and Maria in St. Petersburg and reunite them with the rest of their family came to an abrupt halt in 2015. The Russian Orthodox Church asked for more testing, more proof of the authenticity of these remains. The Russian Orthodox Church canonized Nicholas, Alexandra, and their 5 children in 2000. They're considered martyrs. This means that their bones are relics, so the Church wants to be very sure of their authenticity, hence asking for more DNA tests. The investigative committee of the Russian Federation exhumed Tsar Nicholas, Tsarina Alexandra, and Nicholas's father, Tsar Alexander III, for the collection of DNA samples. They also took samples from the blood-stained clothes worn by Nicholas's grandfather, Tsar Alexander II, the day he was assassinated in 1881, and they tried to get access to samples from Alexandra's sister, Grand Duchess Elizabeth Fyodorovna. As we've discussed before, Elizabeth, also called Ella, is buried in Jerusalem, but it's not clear if the investigative committee actually obtained samples from her. In 2018, the investigative committee announced positive results for the comparison of the DNA of Nicholas, Alexander III, and living relatives from amongst the extended Romanov family. Their results supported the father-son relationship between Alexander and Nicholas. But they didn't publish a paper about it. They issued a press release about it, and a bunch of different news outlets reported on it, but there's no article that describes their methods. They could have used Y chromosome short tandem repeats, repetitive chunks of DNA passed from father to son on the Y chromosome, to establish that genetic relationship between the 2 men. That method was used to identify the remains of Nicholas's son Alexei, but it's also not clear if Alexander's DNA was compared with Alexei. The news reports don't mention it, and they also don't mention if extracting DNA from the bloodstained coat of Tsar Alexander II was successful. Both Alexanders, Nicholas, and Alexei would all share the same Y chromosome short tandem repeats, but there isn't much information available about these studies. These studies also didn't result in Tsarevich Alexei and Grand Duchess Maria being buried with the rest of their family. Their remains are still being held in state archives, but this is still not the end of the Romanov DNA studies. Having so much genetic data from the Romanovs available means that all of this data is still useful for answering questions about the past. For an article published in 2021, their DNA was used to verify the value of a relic, a watercolor portrait of Tsarevich Alexei, with a lock of hair enclosed in its frame that's held by the State Historical Museum in Moscow. The researchers wanted to know whether or not the hair actually belonged to Alexei, so they tested 2 hair shafts from the portrait. Though the DNA in the hairs wasn't preserved very well, the mitochondrial DNA sequence obtained from them matched Alexei, Alexandra, and Alexei's sisters. This makes it entirely possible that those hairs belong to Alexei. Another recent Romanov study looks to improve upon the methods used for extracting and analyzing DNA from single rootless hair shafts. For this study, the scientists wanted to test a combination of whole genome sequencing and a DNA extraction protocol that's optimized for targeting ultra-short DNA molecules from single rootless hair shafts with the oldest, and thus very degraded, samples they could find. The oldest hair samples they could access came from 2 items held in a private collection: a pendant that had been made for Tsarina Alexandra, and a framed photo of Tsar Nicholas's maternal grandmother, Queen Louise of Denmark. They compared the mitochondrial DNA sequences obtained from the hairs preserved with these items to the published sequences of Alexandra and Nicholas. All of the sequences from the hairs in the pendant that had been made for Alexandra had the same mitochondrial DNA profile, and they belonged to the mitochondrial haplogroup H1AF2. A mitochondrial haplogroup is a collection of mitochondrial haplotypes, and those are defined by similar genetic variants in their sequences, and the people grouped together in a haplogroup share a common maternal ancestor. Alexandra belongs to haplogroup H1AF2, just like the hairs from the pendant. The hairs in the framed photo are presumed to have come from Queen Louise of Denmark, and the photo had belonged to her daughter, Tsarina Maria Fyodorovna, and then to Maria's daughter, Grand Duchess Xenia, before being passed to other members of the family and then ending up in a private collection. Louise was Tsar Nicholas's maternal grandmother, so the mitochondrial DNA sequences from the hair in the framed photograph were compared to him. The sequences matched, sharing the same mitochondrial haplogroup, T2A1A, and sharing the same point heteroplasmy mutation at position 16169 in their sequences. So this means that if the hairs belonged to Queen Louise, then she carried the point heteroplasmy mutation. She passed it to her daughter, Tsarina Maria Feodorovna, again known before her marriage as Princess Dagmar of Denmark, and Maria then passed it to two of her sons, Tsar Nicholas and Grand Duke George. This mutation didn't last very long within this mitochondrial lineage, at least that's what it looks like with the data we have, and that's why we don't see it in the other descendants of Queen Louise who contributed DNA samples to previous studies. That's the last Romanov DNA study I have for you. For now. This story, from the excavation of that first grave up through the publication of this most recent article, has been going on for almost the entire lifetime of the field of ancient DNA studies. Why is any of this important? That first Romanov DNA study was, in the words of the paper's authors, the first major historical investigation in which both STR and mitochondrial DNA have been used as investigative tools. The use of DNA analysis in this extraordinary case provides a dramatic insight into the power of these techniques in solving historical questions. Nicholas, Alexandra, three of their daughters, their physician, and the three servants were the first historical individuals who had their identities restored to them through a combination of skeletal and DNA analysis. That first study set the stage not only for the identification of other historical individuals through DNA analysis, but for the use of DNA in forensics cases with degraded, poorly preserved DNA. The advancements in DNA extraction and sequencing methods and technology and the application of those advances to the study of ancient DNA and skeletal remains from the archaeological record that made that first Romanov study possible shaped the studies that came later, including the identification of Alexei and Maria and the reevaluation of those original studies. The most recent Romanov DNA study, with the hair from Alexander's pendant and the photo of Queen Louise, pushed the boundaries of DNA technology and its application to degraded DNA. In that study, they managed to get nuclear DNA from those hair shafts. Usually, we're only going to get nuclear DNA from a hair's root, not a rootless shaft. The nuclear DNA results they obtained supported their mitochondrial DNA results, and I don't know if anyone has followed up on these methods and replicated their results with similarly degraded samples, but this can have significant implications for the field of forensic anthropology. Single-shed hairs are often encountered in forensic casework, and hairs collected in older forensic cases might end up being stored in conditions that are not great for the preservation of DNA. So if we can create better methods for getting DNA with degraded samples from single rootless hair shafts, that could really help with forensic cases. If you're interested in reading more about the Romanovs, I have several book recommendations. If you're curious about the whole dynasty, try the Romanovs 1619 to 1918. For Nicholas and Alexandra's family, I really enjoyed the Romanov sisters, The Lost Lives of the Daughters of Nicholas and Alexandra. As part of my research for this series, I reread The Resurrection of the Romanovs, Anastasia, Anna Anderson, and the World's Greatest Royal Mystery, as well as Ella, Princess, Saint, Martyr, a biography of Grand Duchess Elizabeth Feodorovna, Alexandra's sister. There's no shortage of books about this family. Those are just a few I've enjoyed. If you've made it to the end of this series, thank you so much for watching. Because we've made it so far in this series, I made a series because I needed to be a little bit extra about it. I thought, let's do something stupid. Let's see if I can fit the whole family tree that I constructed for this video series onto the board. Don't mind me, I'm just checking the cheat sheets that I bring with me when I film in here. I think there's not even space for me in here. I think this is everyone that we mentioned, everyone we talked about, at least within this family, these various dynasties. But actually, let's go back in, and we're going to highlight everyone whose DNA we probably looked at. We have DNA from Philip. We tried DNA from Ella. We have the whole family here, lost and found. Duke of Fife, George, Countess Senya, Andrew, and then possibly Maria Feodorovna, and possibly Alexander the Third. I think that's everybody. Yep, so just going. No, not Maria Feodorovna, possibly Louise. But yeah, there we go. I probably spent way more time putting all of this together than I ever needed to, but here we are. And again, if you've made it through all of this craziness, thank you for watching.